This is SpaceTime Series 24, Episode 102. Coming up on SpaceTime, Perseverance collects its first samples from the red planet. The Curiosity Rover celebrates 9 years on Mars. And we asked the question, would it really be safe for humans to fly to Mars? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, it was a case of second time lucky for NASA's Mars Perseverance rover after it successfully collected a sample of the red planet's rocks for the first time. The sample target was a briefcase-sized rock, part of a kilometre-long ridgeline of rock outcrops and boulders inside Jezero Crater. The location is a dried-up lake bed near an ancient river delta. Sediments washed down from upstream provide a rich assortment of minerals for sampling. The newly acquired drill core sample will be the first of more than 40 to be taken and stored for eventual return to Earth. That'll be done by a future joint mission between NASA and the European Space Agency. Perseverance's sampling and caching system uses a rotary percussive drill and hollow coring bit at the end of its 2-metre-long robotic arm. This is designed to extract samples slightly thicker than an average pencil, forcing them directly into a hollow tube fitted inside the drill bit. After completing drilling, Perseverance then manoeuvres the corer, bit and open end of the sample tube into position to be imaged by the rover's Mastcam-Z instrument in order to confirm that the sample acquisition did in fact take place. The initial images show intact rock and regolith samples inside the titanium sample tube. But mission managers are waiting for better light to take additional images in order to confirm the acquisition. That follows last month's failed sampling attempt. The drill cut into the rock as intended, but when it pulled back, there was nothing inside the sample tube. Apparently the sample was so fine, it literally fell out of the tube as it was being extracted. If the follow-up images confirm sample acquisition, the sample tube will be sealed and moved to an internal caching system inside the rover for long-term storage. While geology plays an important part in Perseverance's mission to Mars, astrobiology, including the search for signs of ancient microbial life on the red planet, remain the mission's primary objective. But Perseverance is also characterizing the planet's geology and past climate, paving the way for eventual human exploration of the red planet. This is SpaceTime. Still to come, the Curiosity Rover celebrates 9 years on Mars, and we ask the question, will it be safe for humans to fly to Mars? All that and more still to come on SpaceTime. Well, while Perseverance celebrates its first successful drilling attempt, its sister rover Curiosity has just drilled its 32nd hole on the surface of Mars, in the process marking 9 years of exploration in Gale Crater. The car-sized 6-wheeled mobile laboratory touched down on August 5, 2012, on a mission to determine if Mars was ever habitable enough to accommodate life. Scientists are studying why the red planet, once a warm, wet world, has transformed into the freeze-dried desert it is today. And when it was a warm, wet world, was it really capable of supporting life? See, for life to occur on a planet, as far as we know, it requires liquid water. And so finding evidence of past or present liquid water on Mars was one of Curiosity's primary missions. And it managed to accomplish that, confirming the past presence of liquid water on Mars within its first few weeks on the red planet. It quickly discovered minerals which could only have been created in liquid water. It explored stream beds containing rounded pebbles formed by flowing water, and it found atmospheric traces of methane, a gas which on Earth at least is commonly produced by microbial life, although it can be made by geological processes as well. Curiosity has now travelled more than 26 kilometres since landing on the red planet. The rover is now slowly making its way up the side of the 8-kilometre tall Mount Sharp, the central peak inside the 154-kilometre wide Gale Crater basin. Its latest observations are showing mission managers a panorama of knobbly rocks and rounded hills captured by its MASS camera on its 3,167th Martian day, or SOL. Spacecraft in orbit around Mars show Curiosity is now somewhere between a region enriched with clay minerals and one dominated by salty minerals known as sulfates. The central peak it's now climbing is highly layered, providing an area that can be read almost like a geology book, revealing how the ancient environment changed over time. Curiosity's now started up a path winding between a large hill and a towering butte taller than a four-story building. In the coming year, the rover will drive past these two features and into a narrow canyon before revisiting the Greenbow Pediment, a slope with a sandstone cap that the rover briefly summited last year. This is SpaceTime. Still to come, humans hope to visit Mars sometime during the 2030s, but how safe would such a journey really be? And the September Equinox, the constellation Capricorn, and 2 meteor showers are among the highlights of September Skywatch. All that and more still to come on SpaceTime. The United States hope to launch a multinational manned mission to the red planet Mars sometime during the 2030s. Of course, they've got to make it back to the Moon before then. They'll then use the Moon as a jumping-off point for Mars. But once you have all the technical issues ironed out, and some of them are still pretty insurmountable, the biggest problem facing humans, both returning to the Moon and for that matter undertaking the far longer journey to the red planet Mars, will be the issue of radiation. NASA currently limits an astronaut's total lifetime radiation exposure to 600 millisieverts, but that's still enough to increase an astronaut's chance of dying from cancer by 3%. Now, to put all that in perspective, a 6-month stay on the International Space Station exposes an astronaut to between 50 and 120 millisieverts. But spacecraft like the International Space Station are flying in what's known as low Earth orbit. Here, they're shielded from the worst effects of radiation from the Sun and high-energy galactic cosmic rays from deep space by the Earth's magnetic field and Van Allen radiation belts. These, together with the planet's atmosphere, act like a barrier protecting the Earth's surface and allowing life to thrive. Of course, the Apollo astronauts were forced to fly through the Van Allen radiation belts to get to the Moon, and crews of the upcoming Artemis missions will need to do the same. Passing through the Van Allen radiation belts means increased radiation doses, about the equivalent of a couple of CT scans. And once beyond Earth's protective magnetosphere, the Artemis crews, as were the Apollo crews before them, will be subjected to constant elevated levels of radiation. The Apollo crews suffered from what's known as cosmic ray visual phenomena, sudden spontaneous flashes of light, thought to be caused by subatomic particles passing through the retina or vitreous material in the astronaut's eyes, or through direct interaction with the optic nerve, or possibly through visual centers in the brain. Now, while this effect was most noticed on deep space missions to the Moon, even relatively short excursions to serve as the Hubble Space Telescope, which orbits about 120 kilometers higher up than the space station, was still enough for astronauts to begin to experience cosmic ray visual phenomena. And the bombardment of radiation is constant. Astronauts on the lunar surface or orbiting around the Moon were exposed to around 60 microsieverts of radiation per hour. Now, that's some 200 times higher than normal background radiation on the Earth's surface, and up to 10 times higher than the rate experienced on an average transatlantic passenger flight. Now, what all this means is that the average 180-day journey to Mars will expose humans to radiation levels 2.5 times higher than what astronauts currently experience on the International Space Station. So, sending humans to Mars will require scientists and engineers to overcome a range of technological and safety obstacles. NASA's already been considering limiting missions to Mars to older astronauts whose life expectancy means they don't have as many years left for cancers to develop. Now, a report in the journal Space Weather has looked at the amount of time and the sort of circumstances under which a trip to Mars should be undertaken. They say the entire round trip, including the time on the surface, should be kept to under 4 years, and it should be timed to coincide with solar maximum, the peak of the Sun's 11-year solar cycle. The authors have determined that humans should be able to safely travel to Mars, provided the spacecraft has sufficient shielding. And the timing of the human Mars mission also makes a huge difference. The authors determined the best time for a flight to leave Earth would be at solar max, when the Sun's 11-year solar activity is at its peak. Now that might sound counterintuitive, but it comes about because galactic cosmic ray activity is at its lowest within the 6 to 12 months after the peak of solar activity, and that's because the enhanced solar activity acts to deflect the high-energy galactic cosmic rays. The authors claim we have the technology now to shield a Mars-bound spacecraft from energetic particles from the Sun simply by using a very thick shell. But they say you don't want the shielding to be too thick. That would actually increase the amount of secondary radiation to which the astronauts would be exposed. That's because particles which found their way into the spacecraft would simply bounce around inside it. One of the study's authors, Yuri Spritz from the University of California, Los Angeles, says the average flight to Mars takes about 9 months. So, depending on the timing of the launch and the available fuel, it is plausible that a human mission to the red planet could reach Mars and return to Earth in less than 2 years. He says any longer than 4 years would expose astronauts to a dangerously high amount of radiation during the round trip. The idea of using a more active kind of shielding that simply acts as a barrier similar to Earth's magnetic field was considered. It would be possible using superconducting magnets. The problem is the deflector shield would be huge, very heavy, and just about impractical because of the high energy requirements and constant cooling with liquid nitrogen. So, the good news is the trip to Mars is on again, but only for a limited time. This is SpaceTime. And time now to turn our eyes to the skies and check out the night skies for September on Skywatch. September was the 7th month of the year in the old Roman calendar, which had just 10 months. That's before the addition of January and February. That 10-month year is still reflected today in the name September or Septem being Latin for 7, October or Octo meaning 8, November and Novem 9, and December or Deci meaning 10. It really wasn't until the Gregorian calendar that January the 1st marked the start of the new year, but in the beginning it was mostly only Catholic countries that adopted it. Protestant nations only gradually moved across, with the British, for example, not adopting the reformed calendar until 1752. Prior to that date, the British Empire and its American colonies still celebrated the new year on March the 25th, marking the Feast of the Annunciation and Easter. The earliest recordings of a New Year celebration are believed to have taken place in Mesopotamia around 2000 BCE, around the time of the Northern Hemisphere vernal equinox in mid-March. A variety of other dates tied to the seasons are also used by various ancient cultures. The Egyptians, Phoenicians and Persians began their New Year off with the fall equinox, and the Greeks celebrated it on the winter solstice. While the Jewish New Year, or Rosh Hashanah, the Festival of Trumpets, occurs in September, where it marks the beginning of the Northern Hemisphere cycle of sowing, growth and harvest, and apparently the creation of Adam and Eve, according to the Jewish Bible, the Old Testament. This year, the September Equinox takes place at 5:21 in the morning of Thursday, September the 23rd, Australian Eastern Standard Time. That's 3:21 in the afternoon of Wednesday the 22nd of September US Eastern Daylight Time and 19:21 in the evening September 22nd Greenwich Mean Time. The day marks the point in Earth's orbit around the Sun when the planet's rotational axial tilt means the Sun will appear to rise exactly due east to someone standing on the equator. It means almost equal hours of darkness and light. In fact, the word equinox is derived from the Latin, meaning equinus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of around 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun, and Earth's axial tilt is pointed to the same direction in the sky, regardless of Earth's orbital position around the Sun. So on other days of the year, Either the northern or southern hemisphere are tilted more towards the Sun. But on the two equinoxes, around March the 21st and September 23rd, the tilt of Earth's axis is directly perpendicular to the Sun's rays. For those in the northern hemisphere, it means the start of fall or autumn, while those of us south of the equator are moving into spring. Now, it's also worth noting that on geological timescales, the solstices and equinoxes change because of a process called precession, which causes Earth's spinning axis to wobble like the axle of a spinning top. The rate of precession is only about half a degree per century, so people don't notice it on human timescales. But because the direction of Earth's axis of rotation determines at which point in Earth's orbit the seasons occur, precession will cause a particular season to occur at a slightly different time from year to year over a 21,000-year cycle. Of course, as well as precession, the Earth's orbit itself is also subjected to small changes called perturbations. That's because Earth's orbit's an ellipse, and so there's a slow change in its orientation, which gradually shifts the point of perihelion, Earth's closest orbital position to the Sun. Now, these two effects, the precession of the axis of rotation and the change in the orbit's orientation, work together to shift the seasons with respect to perihelion. And because we use a calendar year that's aligned to the occurrence of the seasons, the date of perihelion will gradually regress through this 21,000-year cycle, unless we compensate for it. Okay, let's start our tour of the September night skies by looking towards the east and the constellation of Capricornus, the goat. The name comes from the ancient Greek tale about the demon Typhon emerging from a fissure in the earth and attacking Zeus, the king of gods, during a banquet. The sudden appearance of Typhon scared Pan, the flute-playing goat boy, who tried to escape by turning into a fish and swimming away. However, he realized his cowardice before completing the transformation, and so distracted the demon by playing his flute instead. And this gave Zeus enough time to use a thunderbolt from the heavens to frighten Typhon away. Because of his actions, both cowardly and brave, Zeus placed Pan in the sky forevermore, still in his half-goat, half-fish guise. The brightest star in Capricornus is Delta Capricorni, also known as Deneb Algedi, or the tail of the goat. It's a near neighbour, located just 39 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum and the ultimate speed limit across the universe. Deneb Algedi is a spectral type A white beta Lyra variable eclipsing binary. It's comprised of two stars closely orbiting each other. Now, astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, then there's spectral type K orange stars, and the coolest and least massive stars are known as spectral type M red dwarf stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together, and our Sun is officially classified as a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are usually about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. As we mentioned earlier, Deneb Algedi is a beta Lyra variable eclipsing binary system. It's made up of two stars closely orbiting each other. The total brightness of the system changes, because the two component stars periodically pass in front of each other as seen from Earth, thereby blocking out the light from the other star in the system. The two component stars of Beta Lyrae systems are usually massive giants or supergiants, so close to each other that their shapes are heavily distorted by their mutual gravitational forces. This gives each of the stars in the system an ellipsoidal shape with extensive mass flows from one component to the other. Just below Capricornus on the eastern horizon, you'll see the constellation Aquarius, the water carrier to the gods. Greek mythology describes Aquarius as the most beautiful-looking boy that ever lived, and so was carried from Earth up to Mount Olympus by Zeus in the guise of Aquila the eagle to become the water carrier. The two brightest stars in Aquarius are Alpha and Beta Aquarii, a pair of luminous yellow supergiants that were once spectral type B blue-white stars. The pair are moving through space perpendicular to the plane of the Milky Way galaxy. Beta Aquarii, the brightest of the pair, is also known as Sedal Sud. It's a multiple star system, located about 540 light-years away. The primary star is about 6 times the mass of the Sun, but emits roughly 2,300 times the Sun's luminosity, implying a radius at least 50 times that of our Sun. Beta Aquarii appears to have at least 2 faint companion stars, but you'll need a decent-sized telescope to see them. The second brightest star in Aquarius is Alpha Aquarii, also known as Sedal Melik. It's about 520 light-years away, around 6.5 times as massive as the Sun, and some 3,000 times as luminous. Next, we move to the southern constellation of Pisces Austrinus, the Southern Fish. The brightest star in the constellation is Fomalhaut, the mouth of the Southern Fish, and the 18th brightest star in the night sky. Interestingly, thousands of years ago, it was used to mark the position of the winter solstice, the Sun's most southerly position as seen from the northern hemisphere. But the precession of the equinoxes, which we talked about earlier, has now moved the northern winter solstice to its new position in December. Located only 25 light-years away, Fomalhaut is a spectral type A white-yellow star, about twice the mass of the Sun and around 16 times as luminous. It's also a really young star, only about 400 million years old. By comparison, our own star, the Sun, is some 4.6 billion years of age. Fomalhaut exhibits an excess of infrared radiation, indicating that it's surrounded by a circumstellar disk. It's also part of a triple star system, together with a spectral type K orange dwarf star TW Pisces Austrini and a spectral type M red dwarf star LP 876-10. Turning to the north now, there you'll see the constellation Pegasus, the winged horse of Greek mythology. Pegasus is the one who delivered Medusa's head to Polydectes, after which he travelled to Mount Olympus in order to become the bearer of thunder and lightning bolts for Zeus. The brightest star in Pegasus is the orange supergiant Epsilon Perseids, which marks the horse's muzzle. Almost 12 times the mass of the Sun, it's blurted out to a spectral type K supergiant nearing the end of its life. Astronomers are still debating as to whether it will end its days as a core collapse supernova or a rare neon oxygen white dwarf. Also in the north is the constellation Cygnus the Swan, which lies on the plane of the Milky Way galaxy. Cygnus contains the star Deneb, one of the brightest stars in the night sky and one of the corners of the Summer Triangle. It's also home to the giant Cygnus OB2 stellar association, which includes one of the largest known stars in the universe, MNL Cygni, a red hypergiant, about 1,183 times the radius and 50 times the mass of our Sun. In fact, were it placed at the centre of our solar system where the Sun is, its surface would extend out beyond the orbit of Jupiter. It's so big it contains a volume approximately 1.6 billion times that of the Sun. NML Cygni is located about 5,300 light-years away. Now, Cygnus is also home to Cygnus X1, a powerful galactic X-ray source which became the first widely accepted black hole. It was discovered back in 1964, and even today it remains one of the most studied astronomical objects in the sky. The black hole is estimated to have about 14.8 times the mass of our Sun, all crammed into an event horizon with a radius of just 44 kilometres. Little wonder black holes are the densest objects in the universe. Located just above the northern horizon this time of the year is the star Vega. It's the brightest star in the constellation Lyra and the 5th brightest star in the night sky. Vega has about twice the mass of our Sun, and it's a relatively young star, less than 500 million years old, and it's also fairly close, just 25 light years away. Now, once again, due to the precession of Earth's rotational axis, Vega used to be the northern pole star around 14,000 years ago, and it will do so again in another 12,000 years' time. Just above Vega is Alpha Aquila or Altair, the brightest star in the constellation Aquila. It's a spectral type A white-yellow star with about twice the mass of our Sun. Altair is located really nearby, just 16.7 light years away, and it rotates very rapidly with an equatorial velocity of about 286 kilometers per second, and that's a significant fraction of the star's estimated breakup speed of around 400 kilometers per second. Now, this high rotation rate means Altair isn't spherical, but highly flattened at the poles. Altair is the eye of the eagle that carried Aquarius up to Mount Olympus to become the water bearer for the gods. Looking to the southeast now, and you'll see the bright star Achernar. It's the brightest star of the constellation Eridanus, the river. Located around 140 light years away, Achernar has 7 times the mass and 3,000 times the luminosity of our Sun. The star rotates so rapidly it's elliptical in shape, with its equatorial diameter being about 56% wider than its polar diameter. September also sees the bulk of the Aurigids meteor shower, which is produced as the Earth passes through the debris trail left by the comet KESS C1911N1. KESS is a long-period comet, only reaching the inner solar system every 1800 to 2000 years. Its meteor shower runs between August the 28th and September the 5th. The Aurigids provide up to 5 swift and bright meteors an hour, with its peak just before dawn on September the 1st. It's best viewed from the northern hemisphere as its radiant, that is, the direction the meteors appear to be coming from, lies in the northern sky constellation of Central Auriga. A second meteor shower in the month of September is the Epsilon Perseids, which run from September the 5th to the 21st. Although they're called the Epsilon Perseids, the radiant actually lies closer to the star Beta Perseus or Algol. Now, the Epsilon Perseids should be confused with last month's Perseids meteor shower. That's because while both appear to have their radiant in the constellation Perseus, they're caused by debris trails from 2 very different comets. And now, with more of the September night skies, we're joined by Jonathan Nally, the editor of Australian Sky and Telescope magazine.
Good day, Stuart. Well, we'll start with the Milky Way and some of the more prominent constellations we can see at this time of year. So at mid-evening in September, the Milky Way, that's our home galaxy seen from the inside, is stretching right across the sky from north to south. It's really quite spectacular. If you've got some dark skies, not bright city lights and that sort of thing, but if you've got some dark skies, you can see the Milky Way. And for those of us in the sort of middle latitudes in the southern hemisphere, the centre of the galaxy, the centre of the Milky Way, and the star fields of Scorpius and Sagittarius are more or less directly overhead from cities like Sydney and other ones that are near enough to that sort of latitude. So it really does look amazing. This region is great to view, even just with a pair of binoculars. If you've got some binoculars, get outside and just look straight up, basically, into the Milky Way. But do try and get away from any sources of nearby light pollution like street lights or your neighbour's light out the back or something. Try and get somewhere dark.
And it also helps you give yourself time to adjust as well in terms of your own eyesight.
Yeah, give your eyes 20 minutes or so to adjust at least, and by that we both mean don't stare into any light. So Go outside and get yourself into somewhere dark. You might have to stand in around the side of the house or something in shadow where no light shining.
Yeah, give the neighbours something to talk about.
That's right. Just creep around in the night. No one's ever bothered by that, is it? Us poor old astronomers. So way down south, we've got the Southern Cross. It's lying on its right-hand side at the moment, this time of the year, with the 2 bright pointer stars above it. If you have really dark skies and you let your eyes adapt to the dark, as we were saying, see if you can spot a dark patch just next to the Southern Cross. This is a huge cloud of dark dust and gas floating in space, and it's called the Coal Sack. It's a dark nebula. It's just next to the Southern Cross. And just near the left-hand star in the cross, and at the moment that's the one that's highest, that's because cross is lying on its side, there's a little cluster of stars called the Jewel Box. And even the pair of binoculars will show you the Jewel Box, and it's really beautiful to see. It's really pretty because some of them are white and some of them have got colours. So it's a really lovely little dense cluster
Blues
of
and oranges and reds
stars.
and whites and yellows. That's stunning.
It is really, really nice, yeah, and you can see them with binoculars, so it's really good to have a look. As the night goes on and the Earth turns, the stars will appear to move towards the west, with some going below the western horizon and others coming up in the east. That's just the way it works. The eastern part of the sky will seem quite bare at this time of year, all the way through till after midnight, about 1 a.m. or so. But then we start to see the mighty constellation Orion starting to rise up over the horizon.
The summer constellation here in the south.
Yeah, for astronomers in the southern hemisphere, this means that summer is coming, not too far away, because Orion is making its appearance. For our friends in the northern half of the planet, it signifies that winter is coming, as someone apparently famously said on some TV show that I didn't watch. Winter is coming, but for us, summer is coming down here. So this is actually a really good time of the year for stargazing, because in the evening time, we've got Sagittarius and the galactic center overhead there, sort of the last of the winter constellations, and the summer constellations starting to make their appearance in the morning sky, so we get a bit of the best of both winter and summer. Now let's look at the planets. What are the planets doing? In the west after sunset, not far above the horizon, you'll find Mercury. It'll be there all month long, about 10 to 15 degrees above the horizon. It just looks like a small, bright star. And even if you get a pair of binoculars or a small telescope onto it, you're not going to really see anything. It just looks like a small, bright star. But higher up above it, you'll find Venus. Very bright and unmistakable. Venus, you just can't miss. It's so bright. It really is really, really bright. It's one of those things where maybe you're walking along in the evening or you're driving along and you look up and think, goodness me, what is that big, bright star? Well, that's actually Venus. Venus will slowly climb higher and higher as each day passes through September, so you won't have any trouble spotting it. It'll get up really nice and high and really nice and bright. The two giant planets, Jupiter and Saturn, you can see these in the east after sunset. So if you've got a good eastern horizon, you should have no trouble seeing them. They're big and bright. Jupiter is the brighter of the two. Saturn's a little bit dimmer. Just go outside after sunset, look in the east. Now, if you've got a pair of binoculars, have a look at Jupiter, train them on Jupiter, and see if you can spot one or more of the planet's 4 big moons, because this is what Galileo did all those years ago with his little telescope. A pair of binoculars has about the same power as his little old telescope did. So have a look at Jupiter and see if you can see any tiny pinpricks of light on one side or the other of the planet. Maybe it's 1 on this side and 2 on that side, or 3 on this side and 1 on that side. It all depends on where they are in their orbits. But you can see them. You can actually see them just with a pair of binoculars, and it's really amazing to see. And if you go out the next night, you'll see they've moved position because they're all orbiting Jupiter all the time. I just think it's incredible that we can see moons around another planet from this distance. And that was the amazing thing that Galileo discovered all those years ago.
But they do move.
But they do move, yeah. So it showed that the heavens were not unchanging as people had thought for so long.
Or Earth-centric, yes.
Yeah. Now, the planet I have left till last is Mars, and that's because we can't see it at the moment. It's lost in the sun's glare. It's dropped out of sight in the western sunset twilight as the sun's gone down. It's too close to the sun. In fact, in a few weeks' time, it's going to be all the way exactly on the opposite side of the sun from us. So we just can't see it. It's in the solar glare.
Is there a name for that when it's on the other side?
Conjunction.
That's conjunction.
Just a conjunction, yeah. Basically, when two things are in the same direction, you call it a conjunction, yeah. So it's going to be directly on the opposite side of the sun to us on October the 8th, and it's not going to reappear in our skies until December, in fact. So it goes out of view for quite a few months. We're going around in our orbit, and it's going around its orbit, and we're sort of chasing each other. And it's staying over there, and eventually we'll catch up because we go a bit faster.
Yeah, that means NASA press releases will drop significantly over the next few months.
Well, that's what they have to do with the Mars missions too, because when the planet is around the other side of the sun, you can't get any radio signals through, so they have to just store data up, or sometimes reduce the amount of work that the spacecraft do, and just wait until they get back in communication again a few months' time. So yeah, it'll be early December until stargazers will be able to see Mars again, and the planet having disappeared above the western horizon at sunset in December, it'll reappear above the eastern horizon just before sunrise. And that's Stuart, the sky for September.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.